Alright, hello and welcome to my new tutorial series, DE10-Nano projects. And in this video, we're going to see how we can program the EPCS package on the DE10-Nano. And what this will let you do is, we've already seen how to program the FPGA, and the only problem is that when you disconnect power, your design files get wiped because your design is being stored in volatile memory, which means you need to have power for it to remember what you told it to remember. So the EPCS is a device that will store your design in non-volatile memory, which means that as soon as you supply power to the board, it will flash the FPGA or program the FPGA with your design files. So this is going to be a pretty easy video. We're going to be using a design file. We're going to be using our project from video 10 of the Verilog development tutorial series. That is the 8-bit accumulator. If you haven't seen that video, go ahead and check it out. I put the video up in the top left. If you don't want to watch the video, you just want to watch this, you can get the design files from my GitHub repository. Link is in the description. Or if you want to use your own design files from Quartus, that's fine too. Okay, so as you can see behind me, I have the user manual. This is found in the CD download that you can get from Terra6 website. And I'm in the manual folder, and we got the user guide. Link in the description if you don't have this download. I'll put that link in the description. Okay, so I'm assuming you have everything and you're ready to go. I'm assuming you have your board ready to go on the table. I got mine all set up. And yeah, let's go ahead and get started. Okay, so we're going to zoom on through. Oh, I need to be in the corner. Okay, that's better. We're going to zoom down to Chapter 8 of the manual, Programming the EPCS Device. And this is going to be a really simple walkthrough. We're not going to be spending a whole lot of time here. Okay, step number 1. Get these switches like that. Go ahead and do that. I already have mine set like that, so go ahead and do that. All right, next up, we're going to take our SOF file and convert it to a JIC file. I believe up here it says JIC is JTAG Indirect Configuration, and I don't know what SOF stands for, but I know that SOF, yeah, it says it right here. SOF file is generated after a successful compilation in Quartus. Cool, so if we open up Quartus, there is, under File, there is a Convert Programming Files. So let's go ahead and do that. I have here the byte accumulator. I'll go File, Convert Programming Files. Let me get those instructions back. All right, select JTAG Indirect, JIC, okay. And then for the configuration device, we're going to do EPCS64. There it is all the way at the bottom for me. Choose active serial. We have that, good. Set a directory and a file name. Click the dots. I mean, right there is fine. I don't care. And I'm going to leave it as output file. I don't care. You can name it whatever you like. Now in the box below, we're going to click on SOF data. So click right on the text here, and then click on add file. Let me scroll down on the instructions. Yeah, click add file. We're going to click number 7 here, add file. So we'll click on that, and we go into the output files folder of our project directory, and here is this SOF file. It's the only type that it wants. We'll click open. Very good. Now we can click on Flash Loader and click add device. So click on Flash Loader, click add device, and we want to add. Oh, it appears the window showed up down here. There we go. We're going to do the Cyclone 5. And this is the Cyclone 5 CSD. What is it? Ooh. All right, I'm sure it'll tell us in the instructions. There it is. CSE BA6. I couldn't remember that. CSE BA6. Check that box. Click OK. All right, and then click Convert Programming Files. Click Generate. Okay. Click Generate. And it's going to go ahead and generate that successfully. Awesome. And we can click close. Cool. So we just generated our JIC file, JTAG indirect configuration file. Okay. So now we're going to actually burn it to the EPCS. So I did a little bit of reading on what EPCS is. I guess it's supposed to be like a next generation of an EEPROM, but basically it's the EEPROM stands for electronically erasable programmable read-only memory. EEPROM. So the point is you have read-only memory, but how do you set read-only memory? Well, you need programmable read-only memory. So they came out with programmable read-only memory. But then sometimes you want to erase what's on there. So they have erasable programmable read-only memory. And I believe from one of my professors, he was like, yeah, we had an EEPROM, not an EEPROM, we had an EEPROM. And what you had to do is you had to like peel back the top of it and expose the inside of this small like ASIC chip and then put it out in the sunlight. And then the sun erased all of the memory and put it all back to zeros. And then you put the lid back on, and then you can program it and erase it and then program it. And then they came out with EEPROM, which is electronically erasable programmable read-only memory. And that was where you can electronically erase it. You didn't have to hold it out in the sunlight and wait some time. Anyways, just a little random tidbit. And then I don't know what the deal is with this EPCS, but it just sounds like read-only memory that you can program. So good deal. Okay, so we already set the dip switches here. We're going to get a programmer. So tools, back on the Quartus, tools programmer. Go ahead and connect power to your board if you haven't already. Let's come back over to the desktop. We're going to select our DE SoC. Oh, sorry, I got distracted by my board because the other day when I was trying this out for the first time, it remembered my design files. I was distracted by those blinking lights. This is actually running video 11, the 7-segment display. Unfortunately, I left my 7-segment display and I only have one, and I left it at my desk at work. So I'm going to be doing a different. I'm doing the byte accumulator instead of the 7-segment, but it's the same idea. It should work with all of them. It doesn't really matter. Okay. We're going to select the program file, select the JIC. Okay, so we'll go back to Quartus. We're going to select the program file, and we're going to select our newly generated JIC. We'll click Open. And then now we can click on Program Configure Box. So it should look like this. Check that box for Program Configure. And then I think we just click Start. Click Start the program. Okay, we're going to click Start. Now this, when I did it the first time, this takes a really long time to... Oh, look at that. It's going faster. All right, I guess I don't have to pause the video. When I did it the other day, this took like 10 minutes. I was like, oh my gosh, like what is it doing? Did it just start over? Okay. Yeah, okay. So it's gonna, yeah, this is how fast it was going. So I'm gonna pause the recording. We'll come back when this is done. Okay, it says it successfully programmed the board. Let's switch over to the tabletop. And nothing's running right now. These green LEDs should be lighting up. If I disconnect power and then reconnect power, Accumulator. Oh yeah, didn't I program it on the buttons? I thought it was just going to go with the clock, but I only did that for the 7 segment. That's right. Okay. So we have our design running here. Very nice. I forgot how the design even worked. I'm going to disconnect the USB. Cool. So we can use our design, and then, you know, we can disconnect power, pack up our board, take it to, I don't know, to school or to a friend's house or wherever, and then we can just plug it back in and say, look what I made. It works. Or if you're, you know, because this is a development kit. You're not going to actually use this for production, I would hope. But anyways, yeah, that's our video for today. Oh, while it was loading, I opened up the manual. I already had the manual open. I just scrolled up. Here's this picture, and there is the EPCS 64 on the bottom. So let's go to the tabletop and just take a look at this thing that's making this wonderful magic happen. That chip right there, right? There's a glare, sorry about that. Yep, here it is. It looks different than the... It looks different. Anyways, it looks different than the screenshot. The screenshot looks much bigger. What is theirs? I'm just curious. The video's over. Thank you for watching. I am just curious though. What does that say on there? EPCS 64N. And this is... There's nothing on there. There's no letters on the package. Anyways, okay, so new tutorial series. Be on the lookout for the next ones coming up. I do want to cover how to program the HPS, or the hard processor core. I believe that's what HPS stands for, but they can call it whatever they want. Yeah, this right here, hard processor system. I call it a microcontroller. It's an ARM microcontroller. We're going to be looking at how to control that. It is basically embedded in the FPGA fabric, and I have never worked with a chip like this before. That's the system on chip. We're going to be looking at how do we interface between the HPS and the FPGA, and we can make some cool projects with that. There is a ADC on board that we should probably look at how to use. There's probably some, you know, the Ethernet, the HDMI, all these things we're going to be looking into. And, you know, it makes sense to have both an FPGA with a microcontroller, you know, because like you can have your high-tech design on the FPGA, but it is not very fun, or it can be difficult to get that design connected to the internet. You know, you'd have to basically have a soft core, like a soft IP core, or you know, your own data path, and it's going to have to be able to interface with some sort of, you know, wireless, you know, Wi-Fi enabled board, and communicate probably using SPI or using some sort of interface. But having that microcontroller to do that boilerplate work really helps out with getting our design connected and actually on the internet. So thank you so much for watching, and I will see you in the next one. Take care. Bye.